Hi everybody, today we're talking about probabilities with and, or, and not. Say you're watching the morning weather and learn there's a 40% chance of rain. What's the chance it won't rain? Our sample space consists of only two outcomes. Either it rains or it doesn't rain. Because the probability of rain is 40%, the probability that it doesn't rain is 100 minus 40%, which is 60%. We call this the complement rule. The complement of an event E, denoted E prime, is the event that E does not occur. The probability of E prime is equal to 1 minus the probability of E. So if we know the probability that E occurs, we also know the probability that E does not occur. In a medical study with 400 participants, 60 participants experienced weight loss as a side effect. What's the probability that a person selected at random did not experience weight loss as a side effect? The probability of no weight loss will be equal to 1 minus the probability of weight loss. The probability of weight loss was 60 out of our 400 participants, so the probability of no weight loss is 1 minus 60 over 400. We can rewrite that as 1 minus 0.15, which is 0.85 or 85%. An event E and its complement cannot occur at the same time, but many events can have shared outcomes. Let's take a look at a few examples. A dog shelter has 8 dogs. What's the probability the next dog adopted is a puppy? From the 8 dogs, we want to count how many puppies we have. Since we have 2 puppies, we can calculate our probability as 2 over 8, which is 25%. Let's find the probability the next dog adopted is a 2-year-old male. In this case, we're satisfying 2 outcomes. The dog has to be 2 years old, and the dog is a male. In this case, the word and is understood. We're looking for the dog to be 2, and we're looking for the dog to be a male. When we scan through the dogs, we only see one dog that's both a male and 2 years old. Our probability of a 2-year-old dog and being a male would be 1 over 8, which is 12.5%. We're going to switch just one word in the question. Instead of saying 2-year-old male, we're going to say 2-year-old or a male. This time, we're looking for all dogs that are 2 and all dogs that are male. So we'll go through and identify all the male dogs, then identify all the 2-year-old dogs. This time our probability is 6 over 8, which is 75%. As a quick recap, and requires both events to take place, where or requires one, the other, or both outcomes to take place. We'll continue to talk about and, or not in the coming videos.